Hello, good morning. My name is Janice Todvodia, and today I will be presenting on a hardware implementation of LeNet interface engine on a FPGA using Vitis LHS. Let's define it. Objective. The objective of this project focus on evaluating the efficiency of a modern device in running neural networks under different conditions. Specifically, we implement and test LeNet 5, a foundational convolution neural network or CNN using FPGA hardware. The objective of this experiment aim to evaluate the modern device efficiency in running networks under various conditions, increase the investment for businesses in driving further development in AI and ML. Recent advancements in AI ML have made this technology more sophisticated and accessible. Let's move on the motivation slide. The motivation behind this works is driven by several factors. Optimized solution for edge device, focus on compact resources efficient device designs, real-time processing in which parallel processing boosts throughput for tasks such as image recognition. Power efficiency. FPGA offers low power consumption compared to GPUs. Last but not least motivation is customization. FPGA designs can be tailored to optimize latency and performance for specific workloads. What's the background this project? The LeNet 5 architecture, foundations, CNN development by Jan Le Kuhn for digital recognition. Pooling layer, reduce dimensions for improved efficiency. Fully connected layer, in which generates a class probabilities and inputs. The grayscale image is 32 cross 32 pixel with hierarchical feature extraction from edge to digit. Let's move on the background side. Background of LeNet 5. What is the purpose of LeNet 5? The development for handwriting digit recognition task. The and architecture, 7 layers, input, future maps 14 cross 14, fully connected layer, maps 5 cross 5, and full connection and Gaussian connection. These all are the 7 connection layer. And what is the output? Is predict the digit class probability 0 to 9. And key contribution set the foundation for modern CNN and deep learning applications. MNIST. It's a full form of a modified National Institute of Standards and Technologies. What is the purpose of this MNIST? Benchmark dataset for training and testing image processing system. And sorry, image specification. The size is 38 cross 38, and each pixel evaluate a range from 0 to 225. This image shows the imaged dataset, level 5, level 1, level 3 application, widely used for machine learning and computer vision tasks like classification and feature extraction. Methodology, HDL design. module implementation of LeNet 5 layers using hardware description language with pipelining to improve efficiency. Second is C reference model, which is a framework to validate HDL functionality through forward pass simulation, synthetic dataset, randomized input, weights, and basis for robust and controlled testing scenarios. Uh, I used stool for simulate my code for White's LHS for the simulation, synthesis, and resource util, utilization analysis. This is a code, thus a snapshot of the code we develop. It demonstrates how the convolution, pooling, and fully connected layer were modified for FPGA implementation using White's LHS. We synthesized this design to evaluate their performance and resource use. Here, I use 2D convolution functions, which is I use a for the loop, a LeNet prediction function, which predict all the floating points and uh, make a matrix of 5 cross 5. This is the intermediate activation code and forward pass. These all are the 7 layer of LeNet 5. The previous course is show the design, and this is my code test bench. So I use White's LHS for simulate my design and test. So this is a test which show the how the code how my code actually works. I use the image with 32 bits, height 32, and num class 10. These all are my designs, and I use a for loop. And here is the input array for image. Yeah, this is my test bench code, and this is my header. I while add my design and a header in White's LHS. Then after I add a test bench and image all the data. Okay, this is my results, which is show the output other ports at top level control is a Zinc 17,000, ATIX 7, and a Vertex Ultra Scale. This is my output. Our results uh, indicated that changing the activations function had a minimum impact on resource uses. Among the three device based, the Vertex Ultra Scale plus performed the best, offering the lowest resource utilization and shortest latency. This finding the highlight the scalability and efficiency of FPGA-based implementation for CNN like LeNet 5. Discussion and conclusion. While the change in activation functions did have some effect on resource use, it wasn't as much as we had anticipated. If we were to contribute to work on this experiment, we would use more parameters and would ideally use the latest version of White's LHS. The White's, sorry, the Vertex Ultrascale Plus was by far the best out of the three devices as tested due to its low resource use relative to the other two devices as well as its shortest latency. We would also like to use a properly functioning version of a LeNet 5 algorithm with pre-trained value on further test. Okay, thank you. It's my project presentations and it's done. Thank you, Professor.